minus.
All right, there is no snow on Janet's driveway. All right, snow begins to fall at midnight. From midnight to 9 a.m., the snow accumulates. So from midnight to 9 a.m., it accumulates. Got that? At this rate, where t is measured in hours since midnight, she starts removing at 6 a.m. So she wakes up and goes, oh my goodness, I got to get my car out today. So are you okay? That's 6 hours after midnight. At g of t in cubic feet per hour, so g of t is a rate, and so is f of t, cubic feet per hour. She removes it. This is your function. It's a piecewise function. Let me draw it kind of quickly. It would look something like this. If you're doing piecewise, from 0 to 6, say this is 6 right here, it's a flat line. That's solid. This would be an open circle since that right there has no line underneath. All right, and then from 6 to 7, say that's 7, it's going to be way up here at 125, and then 108 from here to 9. And they're both closed. Because you got to look carefully at these symbols right here. These symbols are important. I did not make that line underneath. That's not. I didn't make that a less than or equal to all of a sudden. I was just trying to highlight it. So here's what your function looks like if you want to see a visual for it. Now, how many cubic feet? By the way, this is only removal. Removal. How many cubic feet of snow is accumulated on the driveway at 6 a.m. by 6 a.m.? That has nothing to do. She did not start removing anything. So how much accumulated? You simply integrate 0 to 6 of f of t. The rate function gets integrated. That tells you how much is accumulated. Use your calculator. Put your units on if it asks. Okay, it didn't explicitly say to have units, so you could probably get away with it. Not having it, 3 decimal places. All right, what if it said how much did it accumulate over 9 hours? It's 0 to 9, but do you have to worry about Janet?
Yes.
No, it said accumulate. Janet took it off. Do you still understand it's still accumulated? Even though Janet's taking stuff off, snow is still kind of falling on it?
But if it said how many is...
But if it is accumulated, never mind, that would make a difference. Maybe I'll take that one back. Because that could be a little more confusing if it's saying accumulated. Maybe say how much snow fell. Wouldn't it be better than accumulated? Because she is taking it off, so it would affect the accumulating. Because she's not letting it accumulate as quickly. So anyways, 0 to 6. Find the rate of change of the volume of snow on the driveway at 8 a.m. So if I want to know the rate of change of the volume, well, that means the rate of volume. Aren't these volume rates? Aren't those two function volume rates, cubic feet per hour? And it wants to know, so it wants a volume rate at 8. So aren't you just simply going to take function f, which is accumulation, subtract what she takes away at 8, and get my simple answer? And how do you find these two values? Well, you plug 8 into this function. Use your calculator. And you plug 8 into this function, which means, oh, isn't 8 right here in this interval? So isn't it 108 right here? At time 8, isn't it 108? That was an easy one, huh? It's kind of confusing, but the value of this one is just 108. This one, I don't know what it is. Use your calculator. All right. Let h of t represent the total amount of snow in cubic feet. Units are helpful to tell you what you're dealing with. This is amount, which it says right there, but has removed from the driveway at time t after midnight, because the whole process is after midnight, if you remember from the question above. H is a piecewise defined function with domain 0 to 9. Okay, so what she's removed, you want a function. Because g of t up here is cubic feet per hour of what she removed. So it's the rate. G of t is the rate of what she removed. Got it? We want the actual amount she has moved. So there's a difference there. Rates versus amounts. There's something doing with integration. Could go from a rate to an amount. So if I want to find the equation, well, let's pull this thing down and take a look. Okay, here's the answer. It's going to take some space here. So when we look at it, are we okay that at time 0 she had the rate at which, sorry, the amount is nothing, she's removed. All right, from 0 to 6, well, to find how much you removed, aren't you starting at nothing? Got it? And aren't you adding, for removal, the integral of g of s from 0 to t? If we want a function, aren't we going from 0 to t? Because we don't know, we're making a function out. We're not actually finding the actual amount, we're making a function. If we want the amount, could we put a number in there? Between 0 and 6? So they want t, and they use g of s just as another variable. And then when you do this, okay, if you take the integral of g of s, well, the integral of g of s, if you look back up here, I need to zoom out a little bit. See right here, what's g of t? It's 0, right? What's the integral of 0? 0. So take the integral of 0 from 0 to 0. That doesn't help much, does it? If you integrate that, aren't you just going to get 0? So I start at 0, I add 0, okay, my function's 0. Because what's the rate at which she moved it from 0 to 6? Nothing. So that first statement's almost stupid. All right, it's almost stupid. But I'm guessing you probably maybe should mention that there's nothing happening for the first 6 hours. Nothing removed. Then we got from 6 to 7. So here we got 6 to 7. So h of 6, what's h of 6? Isn't that 0? Isn't that where we're at from the previous problem? And then we have the function g. Aren't we going from 6 to t somewhere in this interval? So what's the function for g of s? Well, isn't it 125? So are we taking the integral of 125? The integral of 125, isn't that 125t? Or s, sorry, 125s, and then don't you plug in t, and then don't you plug in 6 and subtract the 2? You're taking the integral of this. It will be 125s, and then when you do a fundamental theorem of calculus, plug in t, plug in 6, subtract the 2, you end up with this. Because 0 plus doesn't change anything, right?
So it would make it 125.
The integral of this would look something like this. You would get 125s, and you're going from 6 to t. So you plug in 6, you plug in t. So you plug in t, you plug in 6, subtract the 2, and this right here is a way to write that. So you plug in t minus, you plug that in, and then they pull the GCF out. That's just one way to write it. Then this is your position for h of 7. Okay, actually no, let me start over. H of 7, because you need that where you're at right here. How do you find h of 7? Can I put 7 in right there? Could I put 7 in right there? What's 7 minus 6? 1. What's 1 times 125? So could I put that right there? Now, I went from 7 to 9, the last interval, so aren't you going from 7 to some number? And where did they get 108 from? Right there. You integral 128, aren't you going to have 128s? From 7 to t. So isn't the function going to look exactly the same right here? And where did 125 come from? H of 7. Yeah, the volume at 7, which kind of transfers over each time. So you're kind of repeating yourself. And then you look right here at this problem. The function is 0 for h of t on this interval. The function right here is for 6 to 7. And then this last function is for intervals 7 to 9. And this would give you volumes. This is your volume amount of snow that she has removed, not the rate. And this is called a piecewise function. Always has this little bracket because it's grouping together different pieces over the intervals. The intervals are pretty important. This is a closed interval here, where here, do you see it was open? And then see you have open, it's closed, open. Here it's open, closed. You kind of got to think about it, because at time 6, how much amount is there? Isn't it 0 at time 6? So wouldn't the 0 be part of the 6, not part of the next interval? You see how 0 is part of the 6 right here? So now it can't be part of this one, so that's open. And at 7, well, wouldn't you be part of this rate at 7? Not the next one? So the closed interval is part of this function, not the next function. So you have to be careful on your signs here too. It's kind of picky. All right, the last problem. How many cubic feet of snow are on the driveway at 9 a.m.? Well, this function h of t, was that the amount of snow?
Yes.
No, that's the amount of snow she removed. Okay, so if I want, that's how much she removed. So if I want at 9 a.m. the amount of snow on the driveway, well, don't I have to go back to the original function to see how much is falling minus what's removed? So if we go back to the original function here, isn't that the function for saying how much has fallen? F for fallen. And then isn't h, the function we just made, the function h right here, isn't that how much you removed? So aren't you going to take the amount of this minus this value at 9? So watch carefully. If I look at the answer here, do you see how to find the amount of snow at time 9, don't you have to integrate the rate function of f? Isn't f a function, a rate function? So aren't you have to integrate the rate from 0 to 9 to find the amount of fallen snow from 0 to 9? Okay, so that's the amount of fallen snow. And what is this number right here going to give you? Well, don't you just plug in 9? Isn't that going to give you the amount of snow at that time? Okay. Isn't that what that gives you, h of 9? Amount of snow? She's done in 9 hours. So that gives you the amount of snow in 9 hours. That gives you the amount of snow that's fallen over 9. Subtract the 2. You got your decimal as long as you had a calculator to crunch it. Cubic feet.